Hello, geometry, and welcome to lesson 7.4 on similarity in right triangles. Right, so we've been talking about similar triangles, all this, or similarity, all of this topic. So now we're going to approach it with right triangles. Okay. Alrighty then. All right, so it says when you draw an altitude to the hypotenuse of a right triangle, you create three right triangles. How are the triangles related? So what in the world does this mean? Well, let's take a look. We're going to draw a triangle. I'll do my best. We're going to make this triangle ABC a right triangle like this. So here's my picture. Okay, so here's A, here's B, and let's take the right angle C, and this is our right angle, right? So an altitude is going to be drawn to the hypotenuse. AB is the hypotenuse. So from C, we're going to draw an altitude down to that hypotenuse. And altitude is perpendicular, right? And we'll call this point D. So the question is, how are these three right triangles? So again, you have two small ones now. I call this one, this is the small one. This one is the medium one. And then you have the overall big one, right? How are these three triangles related? Well, they're actually all going to be similar. And here's why, okay? Let's compare first the big triangle, triangle ABC. Again, that's in alphabetic order. To triangle, and let's call it ACD, the small triangle. ACD. And this is going to be, it's going to end up being by angle. I'll show you why. Okay. Here's why. So in this big triangle, you have a right angle at C. Well, of course, in the small triangle, the right angle is at D. So notice that C in the big triangle and D in the small triangle line up. And now, in this picture, the angle that the big triangle and the small triangle both share are A, right? A is in the small triangle and the big triangle. So notice that A is here, so A has to correspond to itself. And that's why these two triangles are similar by angle, because they both have right angles and they both share an angle. So again, we know that angle ACB is congruent to angle ADC, ACB, the right angle in the big triangle, and ADC, the right angle in the small triangle, because they are right angles. And then we also know that angle A is congruent to itself, and that's the reflexive property. And we're good. Now we can do the same thing for the medium triangle here and the big triangle. So triangle ABC is also going to be similar to triangle, and that correspondence would be triangle CBD. The correspondence is very important here. That's what makes these right triangle problems tough, is the correspondence. And again, it's going to be by angle as well. Again, we know they have right angles. So the big triangles is at C. The medium triangles is at D. And then they, I'll do it in green, they share angle B. Right? Angle B is in the big triangle and in the medium triangle. So where B is, that's where B is. Right? So we know that angle ACB is congruent to angle CDB because they are right angles. And then we know that angle B is congruent to itself by the reflexive property. And now there is this idea of, and we talked about it, I think, in lesson 7.1 or 7.2, about how the symmetric, reflexive, and transitive property works for similarity. Because the small and medium triangle are both similar to the big triangle, then all three triangles are similar to each other. So we know that triangle ABC is similar to triangle ACD is similar to triangle CBD. So in this one picture, there are tons of relationships going on, especially between corresponding sides, because we know in similar figures, corresponding sides are proportional, and we can do a lot of fun proportional work with them. All right, great. So let's look at the formal theorem here. So it says the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. Three similar right triangles. Right triangles are similar, right? So again, here's your picture here. Again, they share the right angles, and then the small triangle and the big triangle share angle A. The medium triangle and the big triangle share angle B. And again, here's the correspondence. And again, that's the part that's important. Okay, so let's take a look at this example here. All right, so it says, given that triangle PQR is similar to triangle QSR, what is QS? Okay, now we can use this correspondence here to help, or I can also try to draw the picture and try to see it from that point of view as well, right? So if we take a look at this big triangle PQR, right? Let's ignore that this QS is even here, right? And then let's draw triangle QSR over here, right? Here's triangle QSR. So in QSR, I know this is 9, I know this is 15, but in the big triangle, all I really care about is 20 and 15, right? I want to find the length of QS. So notice that QS is used in the small triangle only, right? It's not used in the big triangle. So this is what I want to find. That's my question mark. So let's see if we can create a correspondence, right, or a proportion involving QS and its corresponding parts. So if I want to find QS, and actually I'm going to call it X, right? It's called X. So QS is in the second triangle. It's in the first and second spots. So QS is going to correspond to PQ in the big triangle, and PQ is a length of 20. I'll just put PQ for right now, but we'll use the numbers in a second. And then the other triangle, the small triangle, gives me two sides, right? Which one's going to correspond to QR in the big triangle? Because that's the only other side I know in the big triangle. Well, QR has to go on the bottom because it's in the big triangle. QR is here and here, corresponds to SR. So SR is the side we must use from the small triangle. So this is my correct proportion based off the similarity, and again, me drawing the two triangles separate. So QS is what I want to find, X. PQ is 20. SR is 9. And QR is 15. There's my proportion. We're going to cross multiply. 15x equals 180. 15x equals 180. And divide by 15. I'm not going to show you that because you are better than that. You don't need me to show you divide by 15. And when you divide by 15, x is 1, 2. X is 12. So that means that QS is going to be 12. Perfect. Okay, let's try one more in this video. Okay, oh, so I'm sorry. Okay, so I had this written down. So there's this idea called the geometric mean, okay? So the geometric mean, we have what's called an arithmetic mean, which is where you take two numbers, you add them and divide by, 2. Or you can take 5 numbers, add them, divide by 5. Well, there's also this thing called the geometric mean. Again, I'm just doing it because you might see it later on. But this is what the geometric mean is. It's a number such that this proportion works, okay? All right. So again, I'm not going to harp on it because we're going to use proportionality. But that's all this is a proportion. Okay? But again, I showed you what geometric mean was. It did my job. Okay, so next. So given triangle ACB, what is CD? Okay? So again, it's going to say geometric mean, altitude, all those fun words. We want to find what CD is. Okay? So because we want to find CD and they give us AD and BD, I think we're going to use the two smaller right triangles. Okay? So we're going to set up, because that's a right angle, so we know the two smaller triangles are similar. So I'm going to set up a similarity statement based off of them. Okay? So triangle ACD, which is going to be this medium triangle, right? Is going to be similar to, now, I know that D is the right angle, so I know that D has to go in its spot. Okay? So now if I look here, A in this medium triangle, and this is tough to see sometimes, is not going to correspond to B in the small triangle. So A and B will not correspond to each other. So I know that since A went first in the medium triangle, B cannot go first. B has to go second and then C is going to go there, right? So the idea here is that I know that A and B are different angles. So when I put A first here, I can't put B first there. This is our correspondence. And I know it's kind of weird because the C and D don't line up, but the D's do because they're both right angles. Okay? And now that we have this, we can now try to solve it for CD. Notice that CD is in both triangles, right? CD is here and CD is here. That's that idea of geometric mean, okay? Now I'm going to start with CD because I want to find it. Let's start with CD in this medium triangle, CD, over. Okay, CD in this triangle corresponds with BD in the second triangle. And then notice that CD is again in the second triangle, in the smaller triangle. It's going to go on the bottom. What corresponds to CD in the first triangle? Well, it's going to be AD. And there's your proportion, right? Notice that the other two numbers used, BD and AD, you have them. So this is a beautiful thing. So we have X over 3.6 equals 6.4 over X. Now, when you have this proportion, you still cross multiply, but now we're doing X times X, and X times X is X squared. Uh-oh. That's okay. 3.6 times 6.4 is 23.04. And now to get these squared gone, you just simply take the square root, and this I think is a nice number, 4.8. Let me double check before I tell you that. The square root of 23.04 is 4.8 even. So that is your length of CD, 4.8. So it's very important you understand the whole similarity between right triangles and able to immediately write down the correspondence of similarity. All right, thanks for watching the first video. Second video is coming up right now.